I'm studying power markets in the context of the energy transition. The objective of my research is to understand how the rules which structure those markets impact the prices and the incentives they implicitly generate. Markets correspond to meeting points for different stakeholders: producers, retailers, aggregators, customers, grid operators. They exchange energy close to real time, but also several years in advance. One particularity of the power market is that the offer is composed by different types of production with different characteristics. For example, some assets are flexible, and some have a variable and non-manageable capacity of production, which depends on meteorological conditions. Electricity is almost entirely non-storable, at least at a reasonable cost. The perfect match between production and demand is therefore essential. It requires a high level of coordination between the different actors at short term, even in real time, but also in the long-term perspective, to guarantee that structural changes, dismantlement, building of new power plants, development of new technologies, will enable an equilibrium. It is therefore important to model those markets for at least two reasons. First, to enable stakeholders to make optimal decisions. For example, if I am a battery owner, should I use the stored energy now or later? And secondly, it is important to model those markets to anticipate the evolutions and transformation of the system in line with the implemented regulation. To study those markets, incentives and contract theory is key. Indeed, the price signal coordinates the actors of the market, and incentives aim to make a decision which depends on market price characteristics, such as price and volatility level, market liquidity, etc. And those characteristics are themselves the result of the implemented market regulation and of the different incentives, such as feed-in tariff for renewable, retail contract structure, and emission certificate allocation. For example, I worked on a model to analyze how the structure of retail contracts can incentivize consumers. In particular, how a demand-side management contract can generate power demand reduction at the scale of a group of consumers who a priori declare themselves ready to make effort when notified to do so. The objective is to achieve a collective effort to match a target. For this study, we use the Mansfield game theory, as this theory involves a large number of small agents who have a very small individual impact, but a large collective one. Electricity is key to decarbonize our economies. It is possible to generate electricity with no or very few emissions, and then electricity can be used as a substitute of other energies to decarbonize some sectors which are currently emitting CO2, such as building, mobility, and industry. To achieve a sustainable energy transition, large amounts of investments have to be made in the power sector. But it is essential to optimize these investments by designing efficient incentives and market organization. This is how I contribute to the transition.